Hi, thank you for taking some time to look at this. I'm Mark Ashcroft. I'm with Pico Technology Limited. I'm the RF Business Development Manager. Here at our stand at the International Microwave Symposium in San Francisco, I have 4 of our 9 sampling oscilloscope models on the stand. All of them here are our 20 gigahertz 9300 family of sampling oscilloscopes. The modern sampling oscilloscope probably represents your lowest cost alternative for visualizing, measuring, for characterizing your microwave, your RF, or your gigabit signals. That's because within a sampling oscilloscope, the extent of RF and microwave circuitry, well, it probably only occupies half of this relatively small footprint instrument. This is a USB controlled or LAN controlled instrument. We're using an external PC to control this. The small footprint allowing the sampling scope to get close to the work that we happen to be doing. Very important to minimize microwave and RF losses. Despite its small footprint, we can have in this box, we can have 2 channels, 4 channels of 20 gigahertz bandwidth. We can have an amazing 15 terasamples per second sampling rate. That's as little as 64 femtoseconds of time resolution in the acquisition that we're making. These are 16-bit devices, so very high vertical resolution as well as time resolution. Let me pull you up now to our highly respected Pico Sample 3 software. The software is Windows-based. It fully supports touchscreen operation, keypad or mouse, whatever you prefer. And if we just have a quick look around, we can see a relatively high-speed, lively, persisted display here. This is because our sampling oscilloscope is one of the fastest on the market, able to sample at over a megasample or at a megasample per second. So this gives us lively update on our screen, whether we're looking at the persisted display or perhaps at a histogram or perhaps at one of the very large range of inbuilt measurements along with all the statistics that you might expect along with that. When we don't have 4 channels inside the box, we can configure the product instead to have, in this instance, a high-speed, differential, deskewable TDR and TDT source. This is a fast pulse generator. So we are able to do differential or single-ended TDT and TDR measurements. Another feature of our software, all of which is included completely free of charge, by the way. Now, for those of you that want to pack in perhaps 4 channels and TDR, TDT capability, or perhaps optical capability along with TDR, TDT, we can also configure like this with our new range of PG900 Pico source differential deskewable fast pulse generators. Essentially the same technology as we saw previously integrated into the scope, but here we package separately. We use the 2 products together, and in this case, of course, we have the flexibility to put our time domain transmission source perhaps remotely from our receiving sampling oscilloscope, giving us more flexibility in the product and enabling us to achieve the particular configuration that we need. So hopefully I've been able to share some of the power of the sampling oscilloscope in visualizing, measuring, characterizing your microwave, your gigabit and your RF waveforms. As I said earlier, the sampling scope probably represents the lowest cost alternative that you've got for just those roles. So what is this rather ropey looking, I suppose you'd say, eye diagram here? Fairly noisy, fairly jittery. Well, this is a live probing of the HDMI data being sent to this 1080p screen. Keep your eyes open for a further announcement and further video to share with you this low-cost, low-invasive probing solution from Pico Technology.